Hey Laura, I'm going to make a video about that question you asked regarding all the different ways to combine two functions. So I'm going to go ahead and switch over here to the camera view. Well, I will as soon as I pull up the camera. Let me get the camera open and then I will connect you to it. There we go. Okay, so let me try that again. Share. Oh, that took longer than it should have, but here we go. Okay, so this is just like the problem that you sent me. So I'm going to pretend like the first problem is quadratic. The f of x, that's our first function, is a x squared minus 8x. And then the second one is this linear function, 7 plus x. That's g of x. So anything that references g of x, we're going to take and add 7 to the input and so on. All right, so there's two things to pay attention to when you're looking at one of these problems. And one of them is whether they have the x here or whether they have a number. I guess on all this one, they didn't put numbers in any of them. All of them just have the x here. All right, so if there's an x here in the last part, it's telling you what kind of input to work with, which means we need an expression that has x in it as our answer. And then how we form that expression is what this says to do. So this just says basically take each expression and add them together. And then we're supposed to simplify them by combining like terms. So f of x is just defined to be this little expression, x squared minus 8x. Now it says to do plus. This plus came from the original statement there. So I did a plus here. And now I write down whatever g of x is. So 7 plus x. So that is the expression that represents adding the two expressions together. I am, though, going to simplify by combining my negative 8x plus to 1x. So that'll give me negative 7x and then plus 7. Okay, so once you have them all the correct terms all strung along, then you want to simplify it by combining any like terms like that, and then you're done. Since there was an x here, there's going to be an expression with x here. They did not give us a specific number to plug in. So this just means take the two expressions and add them. Okay, well, I've got the same thing going on here. This time it means take each expression and subtract. Make sure you use the correct order when you're subtracting because that makes a difference. Which thing you start with when you're subtracting, it'll change the sign on your answer if you're doing it backwards. All right, so f of x is the first one, x squared minus 8x. Now here's another place to be careful. When you're subtracting, if the thing that you're subtracting has more than one term, and this does, it's got two terms, each of these terms are going to be subtracted. So for emphasis, I'm going to put my second function in a set of parentheses. That is g of x. G of x is being subtracted. So what's really going to happen here is we'll end up subtracting 7 and subtracting x, distributing that -1 throughout there. Then I go, so this is my expression, and again, I'm going to combine my like terms. I still have x squared, but now I have negative 8x minus 1x. So that'd be negative 9x, and then minus 7. So that's what you get when you subtract the g of x terms from the f of x terms. Okay, now we're going to move on to multiplication, and it really is just what you think it is. You're going to just take the two expressions and multiply them together. Now, since each expression has two terms, I'm going to wrap parentheses around each one to show the multiplication. So f of x is x squared minus 8x times, with the second set of parentheses, 7 plus x, like that. Okay, so now I'm just going to do the FOIL. So this is the product of the two functions. This is f of x, this is g of x. Let's go ahead and simplify it by doing the distributive property, which is like the x squared times 7 would make 7x squared. The x squared times x would be x cubed. If it's positive, you write plus. If it's negative, you write subtract. All right, so I've done the x squared times each one. Now I'll do the negative 8x times each one. Negative 8x times 7 would be negative 56x. Probably should have just written subtraction there. And then negative 8x times x, that would be negative 8x squared. So I'll just write minus 8x squared. So these are the four terms that come from basically doing a FOIL, if that's what you've been taught to do. All right, so now let's go and put all our like terms together. I always start from the highest power of x. That's kind of a traditional way to write these polynomials. The next one is squared, and we have two of those. So 7x squared minus 8x squared to give us negative 1x squared. So got those done, got the x cubed done. And then the third term is just minus or negative 56x. So that would be a subtraction. Okay, so that is the result of when you multiply them together, you're going to end up getting x to the third because you're multiplying an x from one times x squared from the other somewhere in that multiplication, and that's why there's a cubic term. Okay, the part D is probably the easiest one of all because this just means stack up a fraction with this expression on the top and the g expression on the bottom, and then you're done. So the f of x was that x squared minus 8x. That's going to be my numerator. This is going to be my denominator. So x squared minus 8x over 7 plus x. Like that. So that would be the expression that's represented by dividing the two functions. And then they throw one in here just to remind us, we did this in module 1. When you have an expression like this that has x in the denominator, then you have to be careful about what you can plug in for x. So that's why they're asking about the domain. Even though if you look at each expression separately, they're not limited in what you can plug in for x, so their domains are all real number. But once you stack them up, whichever one ends up on the bottom, we have to make sure we do not use an x value that would make us divide by 0. So this means we cannot use negative 7, because if I added it to positive 7, that would give me 0 in the denominator. So the domain and number, I'm just going to write out in words, and then we'll find out a more formal way. All the numbers except where that denominator 7 plus x equals 0. So I can literally plug in any other number I want unless it makes that denominator 0. So how do we find it? We take that expression and figure out, well, what would make 7 plus x equals 0? Or we've been doing not equal, but whatever it is, it's going to be negative 7. This tells us that x is not allowed to be negative 7 because when I plug it into these three x's, I'll get something up here, but down here I'm going to get 7 plus negative 7. That means I'm dividing by 0, and we can't have that. So I cannot put negative 7 in for x. That's what this means. So lazy math people just say it like that. The domain is everything except 7, but I believe MyLab Math wants us to write it formally. So let me draw a picture just to kind of give us an idea. There's negative 7 on the number line. We literally can use anything else. I'm going to shade the areas that we are allowed to use. I can literally pick any other number on the number line except for negative 7. Okay, so what we do if we have to actually write what the domain is, rather than like this saying what the domain isn't, that's easier because we're just removing one number. If I want to state it in the positive way, say, well, these are the numbers we are allowed to use. What we end up having to do is write a separate interval for each one of these pieces. So the one that points to the left, it is unlimited on the left. So that starts at negative infinity and goes up to negative 7. On it, parentheses around the infinity, because we always put parentheses around those kind of things. In this case, negative 7 is the edge of this window, or the edge of this interval, but it is not included. I can't have it equal that. So we use a parentheses this time to show that it's the edge, it's the cutoff point, but it's not included itself. There's a missing value there. And then we're going to do the same thing for the rest of it. It starts, negative 7 is the lower edge of this, although we can't use negative 7 itself, but it is the edge of this interval, and then it's unlimited as it goes off to the right, like that. So anything with this is almost like having the whole entire number line, and you can see the only thing that there's any weirdness about is that actual number 7. We have the parentheses, which means negative 7 is not included. Now they do one extra really set notation mathy thing here, which is they put a U, which means the union of all the elements in the first set with all the elements in the second set. So this would be, if they wanted us to type it in by hand, maybe that's how we could do it. Or if we're doing multiple choice, we're looking for the one that has that changeover number, which we got by looking at which one was going to be in the denominator, set that equal to 0, and figure out what the x value is. You're basically finding a 0 for this denominator. Once you locate what the bad number is, the one you have to exclude from the domain, you can use that number to set up these two intervals that say basically everything in the number line except that one bad number. Okay. So that's the basics of what's going on here with this notation. If they ever ask for something like, this isn't for this problem, but I think it comes up in another problem. Let's say it says G subtract F of 1, okay? This means that we're going to plug 1 into each one of those functions and then just subtract the answers. So when you have a number here, if there's a number at the end in the parentheses, that means we're plugging 1 into something and working out an answer. So if a number goes in, which is what this tells us, and what's going to come out is a number answer. So we did G of 1. Yeah, so let's do G of 1 right here. So 7 plus 1, that would be 8. So G of 1 is 8. Subtract. So what I'm doing down here, I'm writing 8. That's what when we plugged in 1, we got 8. Subtract, and then F of 1. So go back up to F of X and figure out what it is when X is 1. So 1 squared is 1. 8 times 1 is 8. 1 subtract 8 is negative 7. So F of 1 is negative 7. F of 1 is negative 7. Okay. So I figured out each of these numbers by plugging 1 into the individual expression. The minus in between them is what was in the original notation. At some point, we're going to have to do a subtraction on these. Okay, so to finish this one up, if I subtract a negative number, that's just the same thing as adding a positive number. So our final answer on this is going to be 15. So when a number goes in at the end here, then you're translating everything into numbers to get combined. So your final answer is a number. But if they have a variable here at the end, that just means your final answer is going to be an expression that uses that same variable. Okay, so I hope that helps you a little bit, since that's the one you sent to me. Okay, so if there's anything else, you can hit my office at 10. I give my first test at 11. So if you want to get in there before 10, or call me or something if you have other questions. Okay. All right. We'll see you tomorrow.